All right, so let's go ahead and get started with our first section on fractions. So a fraction, if we just say, let's look at 3/8. The top of this fraction is called the numerator, and the bottom of the fraction is called the denominator. And so all fractions do is represent how many parts we have in the whole. So we have 3 parts out of the total 8 pieces in the whole. And so we have a couple different types of fractions. We have a proper fraction. And so what a proper fraction is a fraction where the numerator is smaller than the denominator. So something like 2/3 or 9/10. And an improper fraction is going to be the opposite of that. So an improper fraction is going to be where the numerator is bigger than the denominator. So we have something like 4/3 or 100/51. And fractions are just another way of representing quotients or division. So let's say we have A/B. This is the same thing as saying A divided by B. So if we have 8/4, this is the same thing as saying 8 divided by 4, which is the same thing as 2. And so let's go ahead and look at prime numbers and composite numbers. So prime numbers have exactly 2 factors, or exactly 2 numbers. Oh, let me go ahead and erase that. Exactly 2 numbers that go into that number. So if we go ahead and look at the first few prime numbers, the first prime number is 2, and we'll see why 1 isn't in a second. 3, 4 is not because it's divisible by 2 as well as 1 in itself. 5 is another prime number, 7, 11, and so on. So as long as they're only divisible by 1 and themselves. And then composite numbers are the opposite of prime numbers. So composite numbers have more than 2 factors. So some examples of composite numbers. The first composite number is 4. Any even number is going to be a composite number because they are divisible by 2. And then 9, 10, and so on. And so one thing to note, if you notice how 1 didn't show up on either of these lists, that is because 1 is neither prime nor composite. And so the reason for that is because prime numbers have exactly 2 factors. 1 is only divisible by itself. And so it only has 1 factor, which means it can't be composite either because it doesn't have more than 2 factors. So let's go ahead and look at an example of prime factorization. And so for this, we're told to write the prime factorization, and prime factorization is done for just a single number. And this is going to be helpful when we start talking about factoring in chapter 6. Let's go ahead and look at the number 72. Now what we're going to do here is we're going to split this into 2 numbers that multiply to 72. Doesn't matter which ones we pick. I'll do 2 times 36. Anytime we get to a prime number, I'm going to circle it. And those can't be broken down anymore because we don't want to introduce any 1s to this. So now I'm going to go ahead and break 36 into, say, 6 times 6. You could have picked another pair. And now both of these can be broken down into 2 times 3, which are both prime. And now that all of the ends of the branches are prime numbers, this gives us our prime factorization. So our prime factorization, we can write a couple ways. One way is just writing out all of these numbers being multiplied. So 2 times 2 times 3 times 2 times 3. Or we can write this by kind of combining these together using some exponents. So we have 3 2's, so 2 cubed times 3 and 3, so 3 squared. And either answer is completely acceptable when this shows up on the homework or test. All right, so let's go ahead and talk more about fractions. So let's look at reducing fractions, which is really important for the entirety of this class as well as all future classes. We always want to make sure fractions are completely reduced. So let's jump into some examples. And so for these, we want to go ahead and write in lowest terms. That's the same thing as asking us to reduce. And so number 1, let's go ahead and reduce 8/14. And we want to find a common factor or some number that goes into both of these. And so 2 goes into both 8 and 14. So we're going to go ahead and divide both of these by 2. So on the top we get 4, and on the bottom we get 7. And now 4 over 7, neither of those have a common factor, and so this is our reduced fraction. Let's go ahead and try another one. So let's go ahead and reduce 10 over 70. So for 10 over 70, we can divide both of these by 10. We could have also divided them by 2, but the bigger number they have in common, the faster we're going to be able to reduce this. And so if I divide both of them by 10, we get 1 over 7, and we're completely reduced. And then let's go ahead and do one more. Let's reduce 72 over 120. So when the numbers are a little bit bigger like this, sometimes it's more helpful to reduce it a couple times if you're not sure what the greatest common factor is. So 72 and 120 are both even. So I'll just take half of both of these, divide both of them by 2. So if we divide the top by 2, we get 36. Divide the bottom by 2, we get 60. And then they're both divisible by 6, so I'll divide both of them by 6. And remember, there's always different ways of doing this. We could have divided them by 12 or by 2. So 36 divided by 6 is 6. 60 divided by 6 is 10. And we can reduce it one more time. So let's reduce 6 by 2 again. And divide 10 by 2. So we get 3 over 5. All right, so now that we can reduce fractions, we can start getting into some other operations with them. And so what we're going to do next is we're going to convert between mixed numbers and improper fractions. And so a mixed number is just when we have a whole number and a fraction. And we're going to be going from that to improper fractions and then the other way around. All right, so let's go ahead and look at first example here. We're told to write 92 fifths as an improper fraction. And so remember, fractions just mean division. And so what we're going to do here is we're just going to go ahead and divide. So we're going to take 92 and divide it by 5. So 5 goes into 9 one time. 1 times 5 is 5. We subtract and we get 4. Bring down the 2. 5 goes into 42 8 times. 8 times 5 is 40. Subtract, and we get a 2. And so this is our whole number on top. So we have 18. And then this is our remainder, and this is what's going to go on top of the fraction. So we get 2 over our original denominator, which was 5. So 18 and 2 fifths. So this is going to an improper fraction. If we wanted to go the other way and convert from a mixed number to an, sorry, that was going to a mixed number. Now if we want to go the other way and convert a mixed number to an improper fraction, let's go ahead and try writing 11 2/3 as an improper fraction. All right, so what we want to do here, this 11 tells us how many whole circles we have. This tells us how many parts are in that whole. So we're going to take the 11 and multiply it by 3, and then add on these 2 extra pieces. So 11 times 3 is 33, plus 2 gives us 35. And then again, we're going to keep the denominator. So we're going to have 35 over our original denominator, which was 3. All right, so this stuff's important so that when we get to multiplying, dividing, adding, and subtracting, we're able to convert when we need to. So let's go ahead and look at multiplying fractions. So the big thing with multiplying fractions is that we always want to multiply straight across. And we don't need a common denominator like we'll need with adding and subtracting. One other thing that's going to be helpful with multiplying fractions, and I'll show you guys both ways, when we multiply, we'll always have to reduce. So you can always reduce at the end. If you have really big numbers to work with though, sometimes it's helpful to reduce first. And so let's go ahead and take a look at an example of both ways, just so you guys can see if you prefer one or the other, and why one of them is more helpful sometimes. So let's go ahead and look at 5/6 multiplied by 3/10. And so this one, let's go ahead and just try multiplying across, and then we'll reduce. So we're gonna have 5 times 3, which is 15, over 6 times 10, which is 60. And then we can reduce by dividing both of these by 5. And so 15 divided by 5 is 3, and 60 divided by 5 is 12. And we can reduce one more time. We can divide both of these by 3. So 3 divided by 3 is 1, and 12 divided by 3 is 4. So again, always making sure you are completely reducing. All right, let's try another one. So this next one, we'll try the other way where we reduce first. So we have 4/7 times 5/8. So what I mean by reducing first is you can always reduce numbers that are on the top and the bottom of a fraction, either fraction. So we can go ahead and reduce this 4 and 8. The 5 and the 7 can't reduce. So 4 and 8 can both be reduced by a 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. And now if we multiply, we don't have to reduce at the end as long as you completely reduced in the step. So 1 times 5 is 5, and 7 times 2 is 14. So no longer working with the 8 and the 4. All right, so one last example, just so you can see what it looks like when we have mixed numbers. Say we have 3 1/3 times 1 3/4. So when we have mixed numbers, we have to put these into improper fractions before we multiply. So remember, we're going to multiply the denominator by the whole number. So 3 times 3 is 9, plus the 1 gives us 10/3. And then we're going to take 4 times 1, which is 4, plus 3, so 7/4. And then I'm going to go ahead and reduce first, so we don't have to reduce at the end. So this 10 and this 4 can be reduced by 2. So 4 divided by 2 is 2, 10 divided by 2 is 5. Check the numbers, make sure nothing else can be reduced. So we have 5 times 7 is 35, and 3 times 2 is 6. All right, so now if we want to go ahead and divide fractions, it's going to work almost exactly the same, but with one extra step. So dividing fractions, we're going to use something called skip, flip, multiply. I know some other teachers use KFC, so keep, flip, change. Let's go ahead and look at an example of how to use either one of these. So let's go ahead and divide 2/7 by 3/10. So first thing we want to do before we start reducing or doing anything, we're going to keep, flip, change, or skip, flip, multiply. So I'm going to keep the first fraction, change this to multiplication, and then flip this one. So we have 2/7 times 10/3. And now it's exactly like we just did. So let's go ahead and check to see if we can reduce anything. 10 and 3 can't reduce, 10 and 7 can't, 2 and 3 can't, 2 and 7 can't. And we can't reduce directly across. It has to be in a numerator and denominator. So 2 times 10 gives us 20, and 7 times 3 gives us 21. So 20 over 21. All right, so let's go ahead and do one last example for dividing fractions. So for this next one, it's going to look a little different. We're given 4/3, and we're told to divide this by 6. So anytime you're working with a fraction, it's easiest if the rest of the numbers are also fractions. So first thing I'm going to do is change this 6 into a fraction, and so we can write it as 6/1. Still have division. And now we can skip, flip, multiply. So I'll skip this first one, keep it the same. Flip our second fraction, so it becomes 1/6. And then we multiply. And I'll go ahead and reduce first. So I'll reduce the 4 and the 6, divide them both by 2. So 4 becomes a 2, 6 becomes a 3. Again, we can't reduce these 3's because they're both in the denominator. So now we have 2 times 1, which is 2, over 3 times 3, which is 9. And so that's it for dividing fractions. And then the last couple of operations are grouped together, adding and subtracting. And so adding and subtracting fractions, the big thing to keep in mind here is that we need a least common denominator. We're also going to call this an LCD, just so we don't have to write this out every single time. So let's go ahead and look at some examples where we don't need to change our denominator. So this first one here, let's say we have 5/11 plus 3/11. For this one, we already have a common denominator. It's 11 in both of them. So now all we're going to do is add the numerators together. So if we have 5/11 and 3/11, we have 8/11 all together. Never adding the denominators, only add the numerators. And it's the exact same thing when we have subtraction. We're just going to be subtracting the numbers instead. So let's say we have 9/10 minus 3/10. Then we have 9 minus 3 is going to give us 6/10. And always reduce. So 6 and 10 can both be divided by 2. So 6 divided by 2 is 3. 10 divided by 2 is 5. All right, but what if we don't have common denominators already? Then we're going to use something called equivalent fractions. So what equivalent fractions are two fractions that have the same value, but they don't look the same. So let's say we have 3/4, and I want a denominator of 12. Then the idea behind this is that in order for them to be equivalent, what I do to the top, I have to do to the bottom, and vice versa. So if I look at 4 going to 12, I have to multiply this 4 by 3 to get to 12. We're always using multiplication. We're not going to use addition or subtraction. And so that means I'm going to do the same to the top and multiply this 3 by 3. And so we get 9/12. So 3/4 and 9/12 are equivalent fractions. And so let's go ahead and look at some examples where we actually have to change the denominator. So this first one here, we're given 7/30 plus 2/45. So for this one, if you notice, we have different denominators. So we know we need to change those. And to figure out what our LCD is going to be, sometimes it's easier to tell just by looking at them. These numbers are a little bit bigger, so I'm going to write out the multiples of each. So we have 30, 60, 90, 120, and I'll stop there just so they don't get too big. Sometimes you'll need to keep going. For 45, we have 45. 45 doubled is 90, and I'm stopping because we already have the LCD. So our LCD is 90. And so what I'm going to go ahead and do is I'm first just going to rewrite those denominators, and then I'm going to figure out what we have to multiply each of these by, and then we have to do that to the numerator. So 30 to 90 has to be multiplied by 3. So then 7 times 3 is going to be 21. And this 45 has to be multiplied by 2. So then 2 times 2 is going to give us a 4. And then if I go ahead and now add these, 21 plus 4 gives us 25 over 90. And always reduce. So we have both of these divisible by 5. 25 divided by 5 is 5. And 90 divided by 5 is 18. All right, so that was one of the uglier ones just because the numbers started off pretty big. So sometimes you'll have to write them out, sometimes you won't. This next one, a little bit nicer. We're given 5/11 minus 2/9. So I'm not going to go ahead and write out all the multiples of these. One trick you can use to figure out the LCD is to just multiply what we have in the denominator. So you'll see a question like this in the homework where it's going to be letters on the bottom instead, but it's the same thing. We're just going to take 11 times 9. And this is helpful here. Over here, not so much. 30 times 45 would have been really big. But if we do it here, our LCD is 99. And it's just kind of guaranteed that both of those go into it since we multiplied them to get to that number. All right, so now let's go ahead and see what we have to multiply these by. So from 11 to 99, we have to multiply that by 9. So 5 times 9 gives us 45. From 9 to 99, we have to multiply by 11. So 2 times 11 is 22. And then subtracting those, 45 minus 22 gives us 23 over 99. And 23 is prime, and it doesn't go into 99, so we cannot reduce this one. All right, so now 2 more examples. This next one, let's go ahead and just do one more actually. Let's go ahead and look at 2 3/8 minus 1 1/2. So this is one with mixed numbers, works the same with addition. But first thing we have to do here, just like when we multiplied, is change these into improper fractions. So we're going to take the 8 times the 2, which is 16, plus 3, so 19 over 8, minus 2 times 1, which is 2, plus 1, which gives us 3 over 2. And now we want to find our LCD. And so the LCD for this one is going to be 8. Since both 2 and 8 go into 8, doesn't have to be bigger than both of the numbers. And now to get from 8 to 8, we don't have to change anything, so we'll keep that 19 up top. And to get from this second fraction, we have to multiply the 2 by 4. And so we multiply this 3 by 4, and we get 12/8. And then if we subtract, we get a 7 over 8. All right, so that's it for our quick fraction review. Next section, we're going to be talking about exponents, order of operations, and inequalities, which we're going to see a whole lot throughout the semester.